Hi everyone, this is the third training session for the software testing fundamentals, where I will be covering Whitebox and Blackbox testing and also validation strategies. Just to give a recap on what we covered in our previous session about the software development lifecycle and the correlation of that with testing. So you can see the software development lifecycle here, which is gathering requirements, planning, designing, coding, testing, delivery and maintenance. That's what we saw in the software testing lifecycle, right? In the left hand side of this flow chart, you can see the roles of the people who are present in projects who actually do this sort of task. So requirement gathering is generally done by business analysts, okay, and project planning and the project plan, which is the output of the planning phase, is usually by team leads and project managers. The system analyst does designing. The output of this is project architecture, the high level design and the low level design, right? For coding, developers do the coding and the source code is the end result of this coding, which is done by developers. Now in the testing phase, testing is done by the testers, and execution of the test cases is done here, and also figuring out what are the defects in the application, and thereafter, after a couple of cycles of the testing, it goes into delivery, where the application is delivered into production, and thereafter it is into the maintenance phase, where regular releases and patches are done for maintaining the application. As discussed in the previous training sessions, if there are defects in the application, those defects result in software failures, right? So it's very important to start testing in the early stages, right? So you suppose you have 4 requests, which is mentioned here on your screen, which is request 1, 2, 3 and 4, right? The first one is a correct requirement. It is designed correctly and developed as per design, and then it's a correct product, right? Now you have a second request, which is the requirement is correct, it is designed as per the requirement, however there are mistakes in development, so therefore you have defects. So this should be picked up in initial reviews, right? So the third request is you have a correct requirement, however the design is incorrect, and then you have a development done by design, so you have errors in the designing phase itself, right? So the product has designing defects. Then look at request 4, which is incorrect requirement. The requirement itself is not gathered correctly, however the designing was done as per requirement correctly and it was developed as per the design, but you have a wrong product, right? So you need to test early in the cycle to ensure that you don't have design defects or wrong products developed, because conducting testing as soon as possible in a development life cycle helps find defects at an early stage, and it reduces the cost of fixing defects. If you look at request 4, if we had picked up the requirement was incorrect in that stage itself, you would have not have had a chance of a requirement level defect, which will take a lot of cost to fix in the final stages of the project. That was just a quick recap about defects, the cost of fixing defects, and trying to test early, and also a quick recap on the software development life cycle. Now here we will be covering Whitebox testing, Blackbox testing and Blackbox testing methods. So we had defined verification and validation in our previous session. So verification we went through, it was peer review, walkthrough and inspection. Now validation, you do it at 2 levels. One is at the low level and the second is at the high level. The low level is unit related, that means source code at the code level, and the second part of the low level validation is integration. So you are doing it at a module level. If you look at the software testing life cycle design, which I showed you earlier. And the high level is functional testing, so, and system testing and acceptance testing. So this is at system integration and acceptance test design phases. So low level corresponds to Whitebox. So you're looking at the code and you're looking at the integration of the code, right? The high level corresponds to Blackbox. So you're not looking at code, you're looking at the system as a black box. So you're just seeing what is the input going into the system, what is the output coming out, and you're not looking at what is going on inside the box. The box is a black box for you. That's why it's called Blackbox. Now, Whitebox testing, like I explained here, it deals with internal logic and structure of the code. And the test cases for Whitebox testing are written based on the code, based on the if statements or the for statements or the branches and paths of the code, and it's based on the internal logic of the code, and it is generally done by developers. How can we do Whitebox testing? You can do it by data coverage, that is, you figure out what are the branches, if conditions, for conditions, and you verify the data coverage there. The second is code coverage, so you go through the code and figure out what kind of testing you need to do there. So data coverage is data flow monitored or examined throughout the program. So you use a monitor window in your code and you look at the values of the variables and expressions and validate that those values are correct and as per your design. Code coverage. Code coverage is a process of finding areas of a program which is not exercised by a set of test cases. So you analyze the test cases you have written, and then you analyze the code and you figure out what is left out, and you ensure maximum coverage. And to do this, you cover all statements, decision trees, conditions throughout the code. Now, the major difference between Whitebox and Blackbox is that in Whitebox you look at code, and in Blackbox you say that I look at the input going into the program, I look at the output coming through the application, and I don't know what goes on in the system, so it's called Blackbox. So the key points which are important to note here are that in Blackbox testing you don't need to have any knowledge of the internal design of code. It is testing done only on the basis of requirements, and you ensure that the functionality of the software application works as per your requirements. So here the tester is required to be thorough about the specifications of the system, which you gather in the requirement phase of the SDLC, right? And as an end user, you should also know how a system should behave if a particular action is performed. So this is very important for Blackbox testing. Now, the most commonly used methods for Blackbox testing are equivalence partitioning, boundary value analysis, and error guessing. Let's get to each one of them. Equivalence partitioning is a technique wherein you create equivalence classes rather than doing exhaustive testing of the entire data. So you divide data into partitions of classes of data, and you test on a sample basis throughout the equivalence partitions that you make. So we say that if we expect the same result from two tests, then you consider those classes equivalent, and they will test the same thing. If there is a bug in one class, you will get the bug in the other class as well. Let's look at an example for you to understand what we mean by equivalence partitioning. So there is a program which edits credit limits within a given range of $10,000 to $15,000. So here, since you're saying it's from $10,000 to $15,000, you have one class which is less than 10,000, which is invalid, between 10 to 15, which is valid, and greater than 15, which is invalid. So you totally have 3 partitions and you test for data values in each of these. Partitioning system inputs and outputs into equivalent sets. So you partition the previous example of less than 10,000, 10,000 to 15,000 and more than 15,000. The aim of this is to minimize the number of test cases to cover the input conditions you're talking of. If you try and cover, say, everything from 0 to 15,000, it's going to be too exhaustive and you won't have that much of time. The next you do is boundary value analysis. Okay, so we say that we have created equivalence partitions and you say that there at the boundary values you have bugs and they lurk in those corners, right? So this is a very famous statement which says bug lurks in corners and congregates at boundaries. So you take the same credit example and you say your range is 10,000 to 15,000. So you do the lower boundary, which is 10,000 minus 1 and plus 1. So you have 9,999, 10,000 and 10,001, right? Exact on the boundary, which is 10,000 and 15,000, and the upper boundary plus and minus 1, which is 14,999 and 15,001. So here this is a technique which focuses on the input and output boundaries of the given function which you're talking about. So you first create your equivalent, you first create equivalence partitions and say that when you created the classes, any set of data you pick up from within the classes, the result is the same. The second thing you should do is boundary value analysis, which is that from the upper and the lower limits you take plus and minus 1 and act exactly at the boundary. So this is the example where you've taken $10,000 to $15,000. You take 9,999, 10,001, that's the lower boundary, 14,999 and 15,001, which is the higher boundary, and exactly at the boundary, which is $10,000 and $15,000. Right? So this is boundary value analysis. So generally, it is seen that there are a large number of errors which tend to occur at the boundaries of the input domains. So you select test cases at the boundary values. Now you can take an example of a loan application where you have a customer name, the account number. The customer name is 2 to 64 characters. The account number is 6 digits and the first is non-zero. Then there is a loan amount requested, which is 500 to 9,000. The term of the loan, which can be between 1 to 30 years. Monthly repayment, of which the minimum is £10. You have term, repayment, interest rate, right? So let's look at this example of a loan application. Now the first character for the account number is, it should be a non-zero. So the valid one is non-zero, invalid is 0. Now if you go back to the account number, it says 6 digits and first is non-zero. So the first digit non-zero, we picked up that value, which is valid, which is non-zero, and invalid, which is 0. The next thing we'll do is pick up 5, 6 and 7. So 5 is invalid, number of digits, 7 is invalid, 6 is valid. Basically your system should tell you that these are invalid combinations and this is a valid combination. So that is how you do equivalence partitioning and boundary value analysis. So this helps you create better test cases and ensures that you don't go in too exhaustively, so that you can test in the limited amount of time which you have for testing and you cover all important aspects of the application for testing, and you can ensure reliability of the application as well. Right. The third is error guessing, which is based on theory that test cases can be developed upon the intuition of the test engineer.